Hello and welcome. My name is Janith Jesudasan and I'm from Virgin. In this video, we are going to look at Health-Based Target Part 2, Implementing Health-Based Target. Part 1 is titled DALI Demystified. If you want to have a look at that, please sign into H2 Operator. Little bit of a background. Now, greatest threat to water safety is the pathogenic microorganisms. Now, we are expected to use multiple barriers to prevent these microorganisms affecting public health. Now, pathogens risk cannot ever be removed to make water 100% safe. So, the aim is to ensure the drinking water has tolerably low risk and therefore considered safe for the customers. Now, everyone perceives risks differently. Now, what is high risk for someone may not be high risk for another. Well, how water suppliers assess their treatment effectiveness to reduce these risks is also subjective. Now, is this acceptable? Everyone using different standards. Well, this is where health-based target comes in. Now, health-based target is a framework that provides a common standard for everyone to assess their risks and treatment to mitigate the risks. Now, this reduces the subjectivity of your assessments. The outcome of less subjective assessment is more confidence in water safety, so better outcome for the customers. Now, what are the aims of health-based targets? Now, the first aim is to provide a common basis for determining the treatment requirements for individual water supplies. Now, to help define the performance standards that apply to treatment processes is the next aim. Now, the third aim is to help prioritize the improvement and investment plans. Now, let's look at the targets. So, 10 to the negative 6 DALI or 1 micro DALI or disability adjusted life years per person per year is the target. Now, DALI is basically the disease burden on a population. Okay, well, think about this. When a person gets an infection that affects their quality of life, it can also result in death. Now, DALI is a number that expresses this disease burden on a population, taking into account the disability and or death on probability, severity, and duration. So remember, probability, severity, and duration. Now, let's put that into an equation. Okay, so DALI equals years of life lost plus years lived with a disability or illness. Now, if you don't understand this, please have a look at my first video in this series. Even if you don't understand any of this, don't worry, because what's coming after this is more important. Now, how do we implement health-based targets? There are 3 steps that are involved in this. The first step is undertake system-specific risk assessments for the source water. Now, we have to use the health-based target framework criteria for this. And then we set the microbial reduction targets. Step 2. Now, we assess the barriers, our treatment barriers, to see if they achieve the target. Now, step 3. Document your assessment and take action if the barriers are inadequate. Now, let's look at specifically step 1. Now, step 1, to undertake system-specific risk assessments for the source water and set microbial reduction targets. Okay, well, how do we do that? This is done through a combination of 2 methods. If we have done things right, the outcome from both methods should be in agreement. However, if they are not in agreement, we may have to do further work to decide which outcome is more accurate. So, the 2 methods are basically sanitary survey. So we look at the presence of dairy, feedlots, etc., and decide, okay, well, we are in category 4. For example, there are 4 categories, so we classify our catchment as one of these 4 categories. Okay, and then we look at the quantitative microbial risk assessment. So for us to do that, we need to have weekly E. coli data, or if not, we can also use cryptosporidium testing data if you've got that. So we can look at that and then say, okay, well, based on this, we think it's catchment 4 as well. It sort of agrees with the sanitary survey. Or we might think, oh, it's no, we don't think it's category 4, it's category 3. Okay, but if you've got the data to justify that, that's fine. Okay, now let's look at the next step. Now I want to introduce the log reduction values here before we go any further. So the log reduction value is pretty simple. Okay, so LRV, or log reduction value of 1, is equivalent to 90% reduction of pathogenic microorganisms in your water. So you start off with 100% and then you remove 90%, then you're achieving a log reduction value of 1. If you are removing 99%, then that's a 2 log reduction, or 2 LRV. And 99.9% is 3 LRV, 99.99 is 4 LRV, and so on and so forth. Okay. Now the third and more important step. Now document your assessment and take action if your barriers are inadequate. So to do this assessment, I'm going to look at the H2 optimizer tool. Okay, so go to disinfection. So note that you have to be logged in to access this. So click on disinfection and then click on health-based target. Okay, so here you enter the name of your system and then go to the source water type. So here you've got surface water and groundwater. Now I'm going to do surface water, but I'm just going to quickly show you what happens when I choose groundwater. So I choose groundwater here, and then here I have to choose whether it's protected groundwater or unprotected with low to moderate risk, or unprotected with moderate to high risk. Say for example, if you are detecting E. coli in your bore water, groundwater, I would say that's as a conservative choice, I would probably go for moderate to high risk. Okay, so when you click on that, as you can see, the LRV requirement is automatically populated. Okay, so I'm going to reset this and I'm going to go back and choose surface water, and then here we have to choose one of the 4 categories for this particular system. Now if you don't understand these categories, click on this question mark, and then you can scroll through and then look at the description and decide, okay, based on the sanitary survey, you are category 2, 3, or 4, or 1. Okay, so in this case I'm going to choose the worst category, category 4, okay, which has sewer urban areas and sewage treatment plants. Weekly test E. coli test results shows more than 2,000 but less than 20,000 E. coli, dairies and feedlots, etc., etc. Okay, so I'll go back here and choose category 4. Okay, as you can see, the log reduction value requirement is populated. Now it is our barrier. To our barriers. Okay, so the first barrier is whether our catchment is protected. Okay, so if you're category 4, your catchment is either unprotected or minimally protected. Okay, so it's a little bit subjective, but if you've done your sanitary survey, then it shouldn't be too hard for you. Okay, so in this case I'm going to say minimally protected. Okay, so what that does is it gives me some log reduction values or some log credits towards my target. Okay, so that's good. Now let's go and look at the next step, which is the raw water storage detention. So the detention in the storage gives us some log reduction credits. However, what you need to remember is that if your storage is covered, then you are not going to get any log reduction value. So I would leave this blank if you have a covered basin. The reason for that is if you have a covered basin, then you are not going to get the natural UV irradiation into your basin, and therefore you're not going to get any microbial reduction through that process. Okay, so if you have a covered basin, I would leave that blank. So I'm going to assume here that I haven't got a covered basin, so I'm going to say my storage is 700 megaliters, and the minimum operating level, it only goes down to say 50%. We don't draw down below that because we are looking at the worst case scenario. Okay, and the peak maximum daily flow out, 31 megaliters a day at a summer peak day. And then so click on that and tells me I've got 11.3 days, and that gives me 1.1 log reduction for bacteria, but I do not get any other log credits for other microorganisms. Now to filter, so you can choose any type of filters here. So I'm going to choose the conventional filtration because I have a clarification process before that. So I'm choosing the traditional conventional filtration. Okay. So there are 4 different classes of filtration. As you can see, each one has a certain criteria. So I'm going to choose class 3. Okay. So individual filtratability less than 0.3. I couldn't quite achieve 0.2, but I am achieving 0.3 NTU for 95% of the time. And also I'm not exceeding 0.5 NTU for more than 15 minutes. Okay. So you can look at the criteria and choose where your filters fit in. As you can see, that's given me some log credits here. Okay, right. So I do not have an ultraviolet system, so I'm going to go, okay, ineffective or no UV treatment, or you can just leave that blank. Okay, so I'm going to leave that blank because I don't have a UV system. All right. So next, let's go and look at our disinfection barrier. So let's choose chlorine for this exercise. You can also choose chloramine. Disinfectant residual at the clear water storage outlet. So I'm running at about, say, 1.5 milligrams a liter coming out of my clear water storage. Minimum water temperature. So in winter, it can get down to, say, 12 degrees. My pH is very close to neutral, so I'm going to say 7.5. Now my clear water storage capacity is 27 megaliters, and the lowest level that it ever gets down to is about 50%. Now the baffle factor, so the baffle factor is basically how mixed your tank is. So if you click on that, it will tell you, if it's 0.1 if it's unbaffled. Agitated basin, very low length to width ratio, high inlet and outlet flow velocities, etc., etc. Okay, so I'm going to choose 0.1 because the lowest baffle factor I can find. Peak outflow rate, the flow out maybe say 270 liters a second, and my outlet water main diameter is roughly about 900 mils. And then the length to my first customer is about 50 meters. So there is a customer 50 meters away. So I want to find out what sort of log reduction that I'm achieving before from the start of my disinfection to the point where the water is supplied to the customer. So calculate. So that tells me I've got 4 log reduction for bacteria, 4 log reduction for virus, 2.9 for Giardia cyst, and no log credits for Cryptosporidium. So as you know, Cryptosporidium is not affected by chlorine dose. Now note that you can always unclick something to get rid of it, because if these things are not particularly a risk for you, you can always turn them off, or you can turn them back on as well. Okay. All right. So now we have done our barriers. Now let's calculate the overall results. Okay. So if you have a look, this is what we are achieving, and this is what we are expected to achieve. So for bacteria, virus, and Giardia, we are achieving either what's expected or more than what's expected. Okay. However, for Cryptosporidium, we are required to achieve 5.5 log reduction value, but we are only achieving 3.5. Okay. So what we can do in this sort of situation is go back here and say, okay, well, how about if I improve my filter performance? How would that change the log reduction values? Okay. So I'm going to go and click class 1 and see, okay, so that's increased slightly. So let's go and have a look at that and then recalculate. Now still I've got one shortfall. Okay. So it looks like I'm going to have to install, I'm going to either have to improve my catchment category by putting the necessary protection, or I'm going to have to put in a UV system. Okay, so let's say if we put a UV system, what's going to happen? So UV dose, I'm going to choose, say, minimum 15 millijoules per square centimeter. Now calculate that. So I'm getting a reasonably high log reduction value for crypto. So that should easily give me the necessary log reduction values I'm required to achieve. Okay, so in this case you can assess, okay, well, as it is, we are not going to be able to achieve. However, by putting in a UV system, we would be able to achieve that. Now the third step is basically document this and then say, okay, well, we have to install a UV system, and that is our safeguard to achieve to the safeguard to protect my system from the microbial risk and to achieve the health-based target of 1 microdali per person per year. Okay, so lastly, if you are doing this as a team, which we recommend that you do, add extra fields. So add as many people as you want. I think you can add up to 8 people. So names of those people who are doing this assessment, and then also the titles. And then you can always screenshot it, print it, document it, so that you know that you've gone through the assessment and these are the outcomes. Okay. Now, thanks for watching, and bye for now.